Good morning, students. Myself, Dhruv Kumar, Assistant Professor, Department of Mechanical Engineering, GIMS Engineering Management Technical Campus, Greater Noida. Today, I am going to present you the third lecture of the Mechatronics, in which we will deal with the following topic: fluid power system, and we can say hydraulic system, okay, and all the associated hydraulic components and the hydraulic, hydraulic machines, right? Come to the point. This is actually in mechatronics we have to go through the two topics. That is what the hydraulics and the pneumatics actuator systems, actuation system. So first of all, I would like to tell you what is actuators. Actuators are output device which convert energy from pressurized hydraulic oil, or you can say in the case of the pneumatic, it may compressed air into the required type of action or the motion, right? In general, if you will tell you, hydraulic or the pneumatic systems are used for gripping or moving operations in industries, and these operations are carried out by using the actuators. So the actuators has been classified into the three types. That is what the linear actuator, rotary actuator, okay, and the actuator to operate flow control valves, right? So about the linear, you are familiar. Linear actuator, the name it signifies, this device convert the hydraulic energy or the pneumatic energy into the rotary motion. That is what we call it the linear actuators, right? Secondly, we are talking about the rotary actuators. So this device convert hydraulic or pneumatic energy into the rotary motion. That is what we call it the rotary. That is what we call it the rotary actuators. Okay, that is what we call it the rotary actuators. And third, the actuator to operate the flow control valves. So these are used to control the flow and the pressure of the fluid, such as, let us suppose we are having the gas as a medium, we are having the steam as a medium, or any liquids we are having. So the construction of hydraulic and the pneumatic linear actuator is totally entirely similar. However, they differ at their operating pressure ranges. Typical pressure of hydraulic cylinder is about the 100 bar, and of the pneumatic system is around 10 bar. So you will see the pressure difference, okay, the difference in the pressure. The typical pressure of the hydraulic cylinder is about the 100 bar, and about the about the pneumatic system is around the 10 bar. So the ratio between these two is 1/10. So if you are talking about actuators, you can say an actuator wherein hydraulic energy is used to impart motion. That is what hydraulic actuators. Okay, or if you are talking about the hydraulic system, so a system wherein energy is imparted to the oil, and this hydraulic energy so imparted to the oil is converted into the mechanical energy. That is what we call it the hydraulic system, right? We call it the hydraulic system. So actuation system are, actuator systems are the elements of control system, and which are responsible for the transforming the output of a microcontroller, or you can say the microprocessor, or you can say the control system, into the controlling action of the machine or the device. I already discussed you all those things. The coded information is transformed into the machine actions. Okay, so see this diagram. Okay, see this diagram. If you'll see this, okay, see this diagram. This is the example is the pneumatic, hydraulic, okay, pneumatic, hydraulic, and other devices. Okay, so let me push a brush. Okay, and now I got it. Okay, so see here, we are talking about the actuation systems, and see this diagram. Actuation system are the element of control system, okay, We are talking about the control loop, closed loop control system. Control system which are responsible for transforming the output of a microcontroller or the microprocessor or the control system into a controlling action of the machine device. Let us suppose see this diagram. For example, if you are talking about the pneumatic, hydraulic, mechanical, and electrical actuation systems. So all are the power oriented device. Pneumatic, the air is using; hydraulic, the oil or other fluids are using; and then mechanical, then electrical, and then these all are the actuation system. We are concerned with that subject. Okay, so see, here you will see this is this is a plant. Okay, I already told you in plant if you are having the robot, autonomous guided vehicle, that is what we call it, the AGV, then numerical control machine or the machine or the vehicle engine. Okay, consumer product, conveyor system, assembly of the systems. Okay, cranes, defense equipments, aircraft engines, and the other machine and the consumer products. Okay, that is going to be the manufacture into the plant. That is going to be manufactured into the plant. That is what we are going to the manufacture into the plant. Okay, okay. So say this diagram. See this diagram. So the whole plant is containing this. Okay. So the plant is having the parameter. Plant is having the parameter. Okay, so see this. This is the sensor associated with the plant. This is the sensors associated with the plant. Sensor is passing the sensor will sense the signal and passes it to the microprocessor and the microcontroller. Okay, okay, and that microprocessor, the microcontroller will have the control codes. Will have the control codes, and they will pass the command signal. They will pass the command signal. They will pass the command signal to the actuators where the mechanical components are mounted. So these actuators will provide the the actuators will provide the actuations motion to the different kinds of the operation, different kind of the operations, right? So first of all, I would like to tell you what are the principle on which hydraulic system is working. What are the principle on which the hydraulic system is working. So I think you are familiar with that subject of the fluid system. Okay, so in the first unit you will go through this principle. Okay, so the mathematical formulation is the same what we are going to discuss over here. Okay, so here you will see the principle of hydraulic system. You will see. Let us suppose we are having the receptacles where the fluid is filled inside this. Okay, and let us suppose we are having the two piston cylinder assembly. Okay, so at the left narrow end we are providing the force F1. Okay, so it will compress the fluid if you are applying the force in downward direction. So the area enclosed by that piston A1, okay, and the area enclosed by the piston A2. Okay, so if we are going to apply the force in the downward direction, so it will compress the fluid. Okay, and that pressure is imparted to the other pistons, which will move them outside with a force F2. So how do we find out the force associated with it? What are the force? What are the magnitude of the force? What we are getting in the form of output. So you will see F2. If you will see F2 into the area enclosed by F1 side. So F2 into A1 is equal to F1 into A2. So how do we find out what is output? We must have to know. So in case of the outputs, we must have to find out what output we are having. So F2 is equal to F1 into A2 by A1. The ratio of the two respective areas. So this is what on which principle. This is what on this principle this fluid system is the hydraulic system is working. Okay, so the hydraulic system is working. Now you will see this hydraulic system. Let us suppose we are having the different component of the hydraulic system. And what are the component of the hydraulic systems? What are the component of the hydraulic systems? You must have to know. The basic element of hydraulic system. The hydraulic pump unit. Basic system I'm telling you the element of an hydraulic system. That is what we can say hydraulic pump unit. Then we can say the control valve, and then we can say in the form of the output, that's the reciprocating cylinder or the rotary motions or rotary motors. Okay, see this diagram. Okay, see this diagram. Okay, this is what this is the fluid tank. This is the fluid tanks where the filter is mounted over here. This is the filter mounted over here. Okay, and this is the input. This is the input from where we are getting the water at the river side. Okay, so what I told you, this is the hydraulic pump unit. In actual hydraulic system, a pump converts the mechanical power into the fluid power. Okay, so the intake of the pump is connected to the liquid source. This is what the intake of the pump is associated with the liquid source. That is what the liquid source, where the fluid is kept into the tank. Okay, so this hydraulic pump, the intake of the hydraulic pump is connected to the liquid source. Usually we are calling the tank, the fluid tank, or the fluid reservoir. Okay, so now we are talking about the control valves. We are having the different kinds of the valves. What are the flow of pressurized liquid discharge by the pump is controlled by valves. And what are those valves? That is the pressure control valve. Pressure control valve, what? It control the liquid pressure. Then flow control valve, what it do? Flow control valve, what it do? It will control the liquid flow rate. And what? Directional control valve, what it does? Then this valve control the direction of the fluid in the liquid. So see, this hydraulic pump associated with this the pressure regulator. Okay, and after regulating the pressure, it send the desired pressure to the control valve. And I already told you what is the function of the flow control valve. It will control the liquid flow rate or rate of the flow. Okay, and then it goes to the this liquid goes to the both direction, that is in the direction of the A and direction of the B. Once it is going to be the assumed in the direction of the A, it will compress, it will pull down the piston inside the cylinder. And when it passes from the B, to the B, it goes up and lift the component what we are looking for. So this is the schematic diagram of the hydraulic system. So this is what actually the piston cylinder assembly, and which is mounted with furnished with the lift at the top, which is furnished with the lift at the top. So what I told you. Hydraulic motor of the cylinder. So the liquid discharge by the pump is directed to the hydraulic motor or cylinder by control valves, by the use of these control valves. So just keep in the mind, we are talking about the hydraulic motor or the cylinder. So the liquid discharge by this pump, okay, is directed to the hydraulic motor, or you can say the cylinder. This is what? Cylinder, okay, by control valve, by the use of the control valves. Okay, so the motor are used where the rotary motion is desired. मोटर हम लोग कहाँ यूज करते हैं? मोटर वी आर यूजिंग वेयर द रोटरी मोशन इज रिक्वायर्ड, एंड द cylinder we are using where the linear motion is required. So as per the requirement we may change accordingly the whole things. Okay, so now we are talking about the applications of the hydraulic system. There are the several applications of the hydraulic systems. Okay, so the hydraulic systems are mainly used for the precise control of the larger force. And the main application of hydraulic system can be classified into the 5 categories. That is what we call it the industrial. They are having the industrial application, mobile hydraulics, automobiles, marine applications, and the aerospace equipments. So industrial applications, I may tell you, the plastic processing machinery, steel making, and the primary metal extractions applications, automated production lines, machine tools, industries, paper industries, loader, crushes, textile machineries, research and development equipment, and the robotic system. All categories comes inside the industrial application. Comes inside the industrial application. What comes inside the industrial application? Comes inside the industrial application. Okay. Come inside the industrial applications. Okay. So now we are discussing about the mobile hydraulics. Mobile hydraulics, you are knowing. Hydraulic is very familiar in the case of the in case of the farming. So mobile hydraulics mean tractors. Tractors. If you are cultivating the land, we are using the hydraulics. So the tractors, irrigation systems, then earth moving equipment like the JCB and others, JCB, caterpillars, okay, all are the player of this segment. Earth moving equipments, material handling equipments, commercial vehicles, tunnel borings. Nowadays, it is very familiar, it is very popular devices. Then equipments, rail equipment, building and the construction machinery and the drilling rigs, etc. These all comes under the hydraulic, mobile hydraulics. Then we are talking about the automobiles. There we are talking about the automobiles. It is used in the system like the brake, okay, shock absorber, steering system, windshield, lift and the cleanings. Nowadays all those facilities are available in different types of the automobiles like cars and the truck, buses. Okay, so these are the facilities. It is along with that vehicles. And now we're talking about the marine application. It mostly covers the oceans, going vessels, fishing boats and the naval equipments. And at last we are talking about the aerospace equipments. Okay, the aerospace equipments. So there are equipment and the systems used for the radar control, okay, landing gear, brake, flight control and the transmission, etc., which are used in the aeroplane, rockets and the space transmission. Okay, so these all are used in the space transmissions. Okay, right? So going to the next. And now we are going to discuss pneumatic and the hydraulic actuation system. So you will see pneumatic deals with the air pressure, okay, and hydraulic deals with the fluid motion and the pressures. Okay, so see this diagram. This is I think people are familiar with this diagram. I think you people are familiar with this diagram. Why? Because this is the diagram of closed loop control system. Here you will see this is the input, this is the desired the output response. Okay, so this is input has been given. Okay, and they are having some errors. Goes to the controller passes the signal to the actuators, and actuator actuate the processes by the help of machine. Okay, if the actual output is same as the actual output produced is same as the desired output, then response will come in the form of the feedback by the use of the sensors. They will measure the actual output and compare it with the desired output, whether it is same or the different. If it is same, then it's all right. Okay, go for the next operation. If it is not all right, then they will pass the signal what problem we are facing, and then rectify the signal, and then go for the other operations. Then go for the next operation. Come to the next. You will see the typical hydraulic power system. With a hydraulic system, pressurized oil is provided by the pump. Okay, with the hydraulic system, pressurized oil, that may be the fluid, is provided by a pump driven by an electrical motor. Okay, pump driven by a electrical motor. Okay, so the pump oil from a sump. Sump is the reservoir or the source. So the pump pumps the oil from the sump through a you will see this diagram. This is the sump, this is the oil reservoir, this is the oil reservoir, and this is the pump. Okay, so pump the oil from the sump through a non-returning valve. This is non-returning valve, through the non-returning valves and an accumulator to the system, from which it returned to the sump. Then it is returned to the sump. You see, from the source, pump is associated with the motor. Pump is associated with the motors, and by the help of the motor, pump is running, and sump they will suck the liquid from the pump and passes it to the non-returning valves, and accumulator to the system, and from which it returned to the sump. Again it passes through it passes through the pressure relief valve. So the desired pressure goes to the accumulator. Desired pressure goes to this accumulator, where it can be accumulated for the output pump, and the rest, which is more than sufficient, which is more than desired, may come return back to this return back to the tank. Okay, return back to the tank. So the pressure relief valve is to release the pressure if rises above the safe limit. What is the role of this pressure relief valve? The pressure relief valve is to release the pressure if it raises the above safe limit. Okay, and then come to the accumulator. The accumulator is a smooth out any short-term fluctuations. Okay, in the output oil pressure. The accumulator is what? Accumulator is to accumulate those energies, accumulate those pressures, in order to overcome any kind of the shortcomings, or in the form of the fluctuation in the output of the pressure oil. And the rest, after receiving those, the rest signals come back to the sump again. Okay, now come to the next. Now we are talking about the accumulator. What is the work of accumulators? Accumulator is a kind of containers, okay, in which oil is held under pressure against an external force, okay, and which involve the gas within the bladder in the chamber, right? In the chamber, you will see this. You will see this. This is the accumulator, where the gas is filled inside this, and this is the bladder, okay, and this is the hydraulic fluid. Okay. So if you see, the accumulator is a kind of the container in which the oil is held under the pressure against an external force, right, and which involves the gas within a bladder, in the chamber. Okay, so it containing the chamber containing the hydraulic fluid, and chamber is containing the hydraulic fluid. Okay, if the oil pressure rises, then bladder become contract. If the oil pressure rises, then bladder contract, increases the volume of oil, and can occupy, so reduce the pressure. Oil can occupy and so reduce the pressure. If the oil pressure falls the bladder, okay, if oil pressure falls, the bladder expand to reduce the volume. Okay, to reduce the volume occupied by the oil. So increase its pressure. So in that case, we need to increase its pressure. So this is somewhat the typical hydraulic power system. Come to the next. What are the advantages of the hydraulic system? Every system is having some advantages and some disadvantages. Okay, so we are talking about the advantages of the hydraulic system. So the hydraulic system uses the incompressible fluid, which results in the higher efficiency. Then it delivers the consistent power output. Which is difficult in pneumatic or the mechanical drive. Okay. Next to this is hydraulic system employs high density incompressible fluid. Incompressible fluid. Possibility of leakage is less in hydraulic system as compared to that in the pneumatic system. So the maintenance cost is very less. The maintenance cost is very less. So this system performs well in hot environment. The system performs well in the hot environment conditions. So these are all about the advantages of the hydraulic system. Now we are talking about the disadvantage of the hydraulic system. So the material of a storage tank, okay, the material of a storage tank, piping, cylinder and piston can be corroded with the hydraulic fluids. Therefore one must be careful while selecting the material for the hydraulic fluids. Okay. Secondly, the structure, weight and size of the system is more, which makes it unstable for the smaller instrument. Okay. And the small impurities, third one, the small impurities in the hydraulic fluid can permanently damage the complete system. Therefore one should be the careful and suitable filter must be installed for the same. Okay. And next to this, the leakage of the hydraulic fluid. Leakage is very severe, leakage is very severe in hydraulic fluids. So the leakage of hydraulic fluid is also a critical issue, and the suitable prevent methods and the seal must be adopted. Okay. And rather than this, at the end of this, the hydraulic fluid is, if not disposed properly, can be harmful to the environment. It can be the harmful for the environment. Right? So go to the next. We are talking about the hydraulic pump. Okay. So the combined pumping and the driving motor unit is known as the hydraulic pump. Okay. So the hydraulic pump takes what are doing? A hydraulic pump takes hydraulic fluid from the storage tank and deliver it to the rest of the hydraulic circuit. In general, the speed of the pump is constant, and the pump delivers an equal volume of oil in each revolution. So the amount and the direction of the fluid flow is controlled by some external mechanism. In some cases, the hydraulic pump itself is operated by the servo control motor, but it makes the system very complex. Okay. So the hydraulic pump are characterized by its flow rate capacity, then power consumption, drive speed, pressures delivered at the outlet, and efficiency of the pump. So continuing with this hydraulic pump. So the pump are not 100% efficient. You all are familiar about this. So the efficiency of the pump can be specified by two ways. That is the two ways to find out the efficiency. One is the volumetric efficiency, and volumetric is the ratio of the actual volume of the fluid delivered to the maximum theoretical value possible. And second is the power efficiency. You can calculate. Second is the power efficiency, which is what? The ratio of the output hydraulic power to the input hydraulic power. Okay, to the input mechanical or the electrical power. So the typical efficiency of pump varies from 98 to 98%. So the hydraulic pump can be classified into the two types. What are those? One is the centrifugal pump, another one is the reciprocating pump. One is the centrifugal pump, another one is the reciprocating pump, another one is the centrifugal pump. So we are talking about the centrifugal pump. See this diagram. Centrifugal pump, what are the function of this is all about the diagram of centrifugal pump. This is about the diagram of the this is the inlet pipe, and this is the outlet pipe. So the centrifugal pumps uses the rotational kinetic energy to deliver the fluids, and the rotational energy typically comes from an engine or electric motor. Okay. So the fluid entered the pump pump impeller along or the near to the rotating axis, accelerates in the propeller, and flange out to the peripheral by centrifugal force, as you will see in this diagram. So in centrifugal pump, the delivery is not constant and varies according to the outlet pressure. So these pumps are not suitable for the high pressure application, okay, and are generally used for the low pressure and the high volume flow application. So the maximum pressure capacity is limited to the 20 to 30 bar, and the specific speed range from 500 to 10,000. So the most of the centrifugal pump are not self-printing, not self-priming, and the pump casing need to be filled with a liquid before it starts. Okay, come to the next. Now we are talking about the reciprocating, and that is what we call the positive displacement pumps. Okay, so the reciprocating pump is a positive plunger pump. Okay, it is also known as the positive displacement pump, or you can say the piston pump. Okay, so it is often used where relatively a small quantity to be handled, and the delivery pressure is quite large. So the construction of this pump, you are getting or not? The reciprocating pump, what I said, this is named as the positive displacement pump, or you can say the piston pump. So it is often used where the relatively a small quantity is to be handled and the delivery pressure is quite large. So the construction of this pump is similar to the 4-stroke engine. You will see this is the same diagram you are getting in the 4-stroke engine. Okay, as shown in the figure. So the crank is driven by some external rotating motor. This crank is driven by some external motor. Okay, some external rotating motor, and the piston of the pump reciprocates due to the crank rotation. So the piston moves down in one half of the crank rotation, and the inlet valves open and fluid enters into the cylinder. Inlet valve, this is what the inlet valve, and this is the outlet valve. Once the inlet valve will open, okay, so the piston will moves down in one half of the crank rotation. The inlet valve open, a fluid enters into the cylinder. In second half crank rotation, the piston moves up. Piston will move up. The outlet valves open and the fluid moves from the outlet. So at a time, only one valve is opened and another is closed. So there is no any fluid leakage. So depending on the area of the cylinder, the pump delivered constant volume of fluid in each cycle, independent to the pressure at the output end. Okay. So with these few topics, we are still looking for new topic to come. So in coming classes, we will discuss the pneumatics and many more consequences regarding to the pneumatic and hydraulic actuation system. Thank you so much for watching this video. Okay.